Today we're going to be talking about section 5.1, which is on bisectors of triangles. First thing we're going to talk about is perpendicular bisector. Now, perpendicular means that it's going to create a right angle. We've talked about perpendicular already. Bisector, bi means two, sector is sections. So two sections that are going to be equal. So if you look over here at this example right here, we see that JK is cut in half by a perpendicular bisector RS. So it forms the right angle right here, and it also means that this side and this side, JR and RK, are going to be congruent. They're going to be the same lengths. So we have two theorems that help us with this. First, it says if a point on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. So essentially it's saying this point right here, C, is going to be the same length from A to C as it is from B to C, because AD and DB are going to be the same length. We also can go the opposite. It says if you have AD the same as BD, and you have AE the same as BE, then it has to be that CE is a perpendicular bisector of AB, meaning it forms a right angle. Let's look at a couple examples. So it says right here, find each measure. So I'm looking at this example over here with triangle ABD. Now it says that BC and DC are the same length. It also says that AC is the perpendicular bisector. See, it forms a right angle. And it says that AD is 4.1. Well, according to the perpendicular bisector theorem, then AB is going to have to be the same length. So AB is going to equal 4.1. Letter B, this one says that we have a perpendicular bisector. Okay? It says that XW is 9 and that XZ is 9. It also says that YZ is 3. So YW is going to have to equal 3 as well. Here's some guided practice problems. Feel free to stop it now and try the problems that are in your notes. Now, when you have 3 or more lines intersect at some common point, they're called concurrent lines. And the point which they all meet is called the point of concurrency. We also have that when they're perpendicular bisectors, it has a special name. And that special name is called the circumcenter. So the point of concurrency on perpendicular bisectors is called the circumcenter. And here's our theorem that says that. The perpendicular bisectors of a triangle intersect at a point called the circumcenter that is equidistant from the vertices of the triangle. So essentially it says right here, here's my point P. And since those are all the perpendicular bisectors, it would say that BP, AP, and CP are all the same in length. Obviously, you can tell then that it's going to be essentially all the same length right there if you just look at the picture. Okay? Now, circumcenters can happen in 3 different locations. When you have an acute triangle, it happens inside. When you have an obtuse triangle, the circumcenter is on the outside. And we have a right triangle, the circumcenter is along the hypotenuse. In fact, it's right in the middle of the hypotenuse. Okay? We have a proof right here that's in your notes. Feel free to look at it if you'd like to see how they can prove that it's going to be the same distance. Otherwise, it's in your notes if you ever need to reference it. So we have an example right here, example 2. It says a stove S, here's my stove, a sink K, here's my sink, and a refrigerator R are all located in a kitchen, just like it's shown. Find the location for the center of an island workstation so that it's the same distance from the 3 points. So what we're looking for, that workstation is going to be the circumcenter of our triangle. So what we have to do is create perpendicular bisectors from each point. And so I'm going to do that, perpendicular bisector. And you'll see that they all meet then at this point right here. So if we wanted our island to be right in the middle of everything, it would be at that red point right there. That would be our island. Here's another guided practice problem. It talks about a triangular garden. Feel free to try this one, pause it, and figure out where the circumcenter of that triangle would be as well. Now the next thing we're going to talk about is angle bisectors. So you can bisect a side. You can also bisect angles. So here are our angle bisector theorems. Okay. First one says if a point is on a bisector of an angle, then it's equidistant from the side of the angle. So we have essentially this angle right here, DBE. And then I have FB, cut it in half so that this side is the same as this side. So what it's saying then, if that's a bisector, then this side, DF, is going to be the same as EF right there. And vice versa, the converse, theorem 5.5, says that if you have something bisect an angle, and you see that FE is the same as FD, then it's going to be true that the angles are going to be congruent, and that it bisects the angle. All right, so here's our example. Find the measure of each one. So we're looking for the length of XY in this one. Well, we see that 41 is the same as 41. WX is 7. So XY, or YX, is going to be 7. Next one. It says that JL and ML are the same length. They're congruent. And we know that LKM is 37. So JKL is going to have to be congruent to it. So it's going to be 37 degrees. Easy enough. Guided practice problems. Stop the video now and try these 3 problems real quick. So just like we had the circumcenter where all of the perpendicular bisectors met, where all the angle bisectors meet is called the incenter. So this point right here is called the incenter. And what it says then is the length from D to P, the length from F to P, and the length from E to P are all going to be the same. So now it's not from the vertices of the triangle, it's from the sides of the triangle. That's where the incenter all meets. So, example 4, find the length of each side if we know that J is the incenter. So this is the incenter right here. So first we know that this length is the same as this length, is the same as this length. Perfect. So we want to find the length of JF. Well, to do that, okay, we can find the length of this one or this one to be the same as JF, right? Those are all going to be the length. So what I'm going to do is I see this triangle right here in green. Side is 12, hypotenuse is 15. We can find the missing side. The way we do that is using the Pythagorean theorem. As a refresher, Pythagorean theorem. A squared plus B squared equals C squared. Remember that C is always our hypotenuse, the longest side. So this one's going to be 15 squared. We'll let B be 12, and I don't know what A is. A squared plus 12 squared is 144. 15 squared is 225. I subtract 144 from both sides. And I find that A squared is equal to 81. which means that my A is the square root of both, so A is 9. So that means this side right here, JE is 9. So how long is JF going to be? JF is going to be 9. Next one, letter B. Letter B says find the measure of angle JAC. Okay? So we need to find what this measure is right here. Okay? So I'm going to look at the triangle as a whole thing right here. Okay? I know that this side is 34, so this side right here is going to be 34 as well. I know that this side is 32, so this side right here is going to be 32 as well. And I don't know what the whole thing is right here. I think back to what triangles have to add up to. They have to add up to 180 degrees. So 34 and 34 is going to be, if I redraw my triangle, it's going to be 68 degrees. And 32 and 32 is going to be 64 degrees. And so I need to know what this side is right here. So I take 180 minus 68 minus 64. And I find that my missing side is going to be 48 degrees. Now, does that mean my answer is 48? No, it means that the whole side right here is 48. And so this side is going to have to be congruent to this side. So I take 48 and divide it by 2 and find that JAC is going to have a length of, or a measurement of 24 degrees. Again, here's another example of a guided practice problem. Feel free to stop and try these real quick.